Okay, so this is a brief set of notes on how do we measure power. So last time around we established that power is the ratio of work to time. So work divided by time gets me power. Now in the metric system, the units that we use here are watts for power. We use the unit joule for work, and we use seconds for time. Now, seconds are a base unit in the metric system. They don't need any further explanation. We know what a second is. So, but a joule is something that's like a little bit foreign to us, right? So joule is being used here as a measurement for work. Okay, so scientifically, work is force times distance. So you have to push something with a certain amount of force over a certain distance. If you do that, you're doing work, and we measure that in joules. So we say that a joule is force, which in the metric system we measure in newtons, times meters. So the N here stands for Newton. So let me just write it out. It's newtons times meters. Now, the meter, again, is a basic unit. We don't need any additional explanation for that. A newton, scientifically speaking, is the amount of force that it takes to accelerate 1 kilogram of mass 1 meter per second per second. So it's like accelerating something 1 meter per second faster every second that goes by. So newtons are something that most people deal with in measurement. We can measure newtons directly by using like something like a spring scale or an accelerometer, things like that. So we're going to use Newton like it's a basic measurement. All right, so let's give some examples of this. Okay, so let's say we have a person and they're exerting 80 newtons of force against an object, and they move it a total of 30 meters. Okay, so that means the amount of work that they did was 80 newtons times 30 meters, which is 240 joules of work. Now, let's say that they did this in a period of 5 seconds. So in 5 seconds, they exerted 80 newtons of force against an object and moved it 30 meters. Then the power that they exerted would be that 240 joules divided by 5 seconds, which comes out to be 48 watts of power. So this is the power that would have been used in order to do that exercise of pushing with 80 newtons of force against an object and moving it 30 meters in 5 seconds. Okay, so let's try a second example. Let's say a second person exerted 200 newtons of force against an object. They moved it only 10 meters, and they did this in a minute, in 60 seconds, right? So the work being done is the 200 newtons by 10 meters, so they did 2,000 joules of work. But how much power was being exerted in this exercise? Well, it's that 2,000 joules, but it took them 60 seconds, a whole minute to do that, which works out to be 33 and 1/3 watts, which is slightly less than what the other person did. So this person definitely did more work, 240 joules of work. this person only did, or this person, sorry, this one did less work, 240 joules of work, but and this one did 2,000 joules of work, but because this one's doing it much faster than this one, we actually are seeing that this person is exhibiting much more power in their work than this one. 48 watts of power here rather than 33 1/3. So these are some basic calculations of power given some basic information, and this is what we're going to do kind of in the next class when we talk about how we measure power. All right, thank you.